right, so what we're going to do now is we're going to take each of these individual parameters, A, B, H, and K, and we're going to examine what happens when the value of those parameters is changed. And I'm going to show you some graphs of examples of functions where a parameter has been changed. We'll be able to compare the before and the after. So we're going to start with parameter A. It's a multiplicative parameter, okay? That means you're multiplying your function by this value A. So what will happen if we change A? The vertical stretch will happen, so the function will be stretched vertically. If the absolute value, let me write this again, if the absolute value, and that means you're disregarding the negative sign if there is one, so if it's 5 or negative 5, the absolute value is just 5 is greater than 1, so we would have a vertical stretch for that case. A vertical compression, so it's going to be smushed downwards if the absolute value of A is between 0 and 1, okay, so if it's some decimal or fraction less than 1. And it will be reflected around the x-axis if A is less than 0. And we don't have the absolute value there. That just means if it's negative, okay, so if the value of A is negative, then we're going to have a reflection about the x-axis. And you can see here that we could have this and either one of the first two happening at once if we have a negative value. So we can have a reflection and a vertical stretch, or a reflection and a compression happening both at the same time. So let's take a look at a couple of examples here. So we'll start with our vertical stretch. And it's probably going to be kind of hard to see, so I'll write this a little bit bigger. This is y is equal to 6x squared. Okay? And this one in black here is y is equal to x squared. So we can see that this is our very basic function, the y is equal to x squared. And this value A is 6. Okay? So if we look back at our notes here, we can see that we have a vertical stretch happening because the absolute value of A is greater than 1. 6 is greater than 1, so I have this vertical stretch. And this is what it looks like. My graph originally was this wider curve here, this black quadratic function, and then what we have is when we multiply it by that parameter A, we end up with a vertically stretched function. We can also have a vertical compression, and I'm going to just highlight the second one in red here because I didn't do that before. Oh no, my shadow's in the way, I can't see what I'm doing. Ah, there we go, close enough. So these are two sine curves. This one right here is 0.2 sine of x. Okay, and this one here is just sine of x, in case you can't read it. And we have a vertical compression. Our value of A is 0.2. Check back with our original slide here. So the absolute value of A is between 0 and 1. Yeah, 0.2 is between 0 and 1. And when we multiply our function, it gets transformed. We have this vertical compression happening. So we can see our original curve, that black curve, is much taller, I guess we could say. And the one that's been transformed with the A value of 0.2 has been compressed vertically. So it's a lot shorter. And our last one here, our original function is y equals x. That's our most basic version of the linear function. And this is our transformed function. Whoa, I can't draw a straight line. Save my life. All right, this one is y is equal to a negative x. So we would say in that case our value of A is a negative 1. Okay, so the value of A in that case is negative 1. And we can see here if A is less than 0, which it is, negative 1 is less than 0, we end up with a reflection around the x-axis. Okay, so we can see that happening here. This y equals x line has been flipped up over the x-axis. It's been reflected, and that's what it looks like here.